Okay, class, Mr. Bean here again, or Bean is here again to help you guys out, give you some hints on EP Physics Unit 1 motion, homework for vertical motion sims. Let's take a look at simulation number 2, dump tower level 1. All right, so it comes up here and let you go ahead and read what it says here. It says this time the tower is located on a planet far away from the reaches of the universe. You'll be asked to determine the acceleration due to gravity of the planet that this tower is on and the impact speed between the object and the planet. Uh, you will measure the time it takes the object to reach the ground at the base of the tower. Okay, so let's take a look and see what's going on here. So we have this here, and the tower is 99 stories tall. A small 2.7 kilogram mass is dumped over the side of the roof here, accelerates toward the ground. You attract the object for its entire fall. Each story of this tower is 2.74 meters. What's the acceleration due to gravity on the planet? And what is the impact speed of the object? Okay, so since we're dropping this straight down, we're not tossing it up, we can go ahead and do our coordinate system. We're going to go ahead and take down to be positive here, down to be positive. Therefore, G will be positive as well. Okay, that's just something just to keep hold of here, and I'm not sure what's going on here. My mouse is not cooperating, and we'll go ahead and say here it is positive here, like so. There we go. All right. So first of all, let's go ahead and find out some things, or let's use the given information, and let's see if we can help us kind of organize our thoughts here and see what we can do. Okay, given. So we'll say delta y is our total height in this case here, because there's only one height. Delta y is going to be, take a quick look here. There are 99 stories, so we'll go ahead and do 99 stories here. Okay, 99 times, and it looks like each story is 2.74 meters in height. So 2.74 meters in height. Okay, this will get us our delta y. Okay, and so let's see, and that's about it. The mass is 2.7 kilograms. So I'm not sure if we need that right now or not. So let's go ahead and click on this and see what we got going on. So we'll click on the ball here, and there it drops. So we now have the total flight time. Okay, so now from here we got the time for impact from starting from rest is going to be 6.37 seconds. 6.37 seconds. Okay. And we also know that VO, the initial speed or initial velocity, is going to be 0 as well. All right. So, two things we can do here. Take a look at some equations that might help us out here. So we already have the time here, right? So let's take a look here. So here's the final velocity is equal to the initial velocity, right? Plus, we'll say GT here. There's G, and here is T. There's GT. And so we want to find what G is, and we have the time here. We know what this is, but we don't know what the final velocity is. So we're kind of stuck there. All right, so over here, let's take a look at this equation over here. It says v squared equals initial velocity squared here, and we'll say plus 2g, right? 2g delta uh, delta y. Okay, so we have delta y. We don't know what g is. We know this is 0. We don't know what this is. We have two unknowns. So these equations aren't going to help us right now. However, there is a third equation. Take a look at that one. It says here that delta y, right? Delta y is going to equal, we'll say here, v o t, right? Plus, right? Plus 1/2. And we'll say here g t squared. All right. I think we can do something here. We have the time. We know this is 0, and we have this. So from here, we can definitely find out what g is. So this will give us g. So here, G will equal something, and we should be able to find out what G is from here. Now that we got G, we can plug it in here because we know time, and we can find a final velocity here. Or we can plug in G here because we know delta Y, we know that's 0, and we can go ahead and solve for V. But this looks like too much work over here, and we'll go ahead and use this over here. All right, that will do it, and hope that helps out. Peace out.